Okay, so here we go. This one over here, we've got to equate coefficients again. So let's go x minus y. I can see immediately that is my real part, right? So my real part is actually equal to
Right,
x.
isn't that the one that I just did?
Yeah. Oh,
Okay.
is that the one you're struggling with? Was it this one or was it another one?
Yeah, I picked that one.
Is it that one? Yeah.
Yeah.
Okay. So yeah, so the real part for this here is x minus y. And on the left hand side, I've got to recreate this. I've got x minus y plus 2x minus y I equals -1. So this basically over here is only the real component like this. That's where we're going to equate the coefficients. And this one here is imaginary, but we don't have an imaginary here, so we can create an imaginary from nothing. So plus 0i. Now, x minus y will equal -1, equation number 1, those two. And 2x minus y equals 0, equation number 2. So therefore, x becomes y plus y minus 1 plus y minus 1. And we can substitute that in for x. So let's substitute that in there. And we will end up with 2 times y minus 1 minus y equals 0. 2y minus 2 minus y equals 0. Y equals 2. We then substitute it back into, let's call this equation number 3 actually, into equation number 3. X equals 2 minus 1. So x equals 1 and y equals 2. Okay, so the question says rewrite or write it in the form a plus bi. I've got 3 minus 2i squared over 5 plus I. And what I want to do now is I want to multiply by the conjugate again. And all I have to do is change whatever sign I have in front of I into the negative. And by doing that, I can rationalize the denominator or bring it into a single number that's real, or realized in the denominator, if you want to call it that, in order to write it in that form. Okay, so that's the first part. This is a difference of squares in my denominator. Okay, so basically this is going to be 5 times 5, which is 25, minus I squared, difference of squares. On top, however, now I've got 3 brackets I've got to solve. I can square the first bracket, right? Let's square the first bracket over here. So 3 minus 2i squared. That's 3 minus 2i, 3 minus 2i. That becomes 9 minus 4, because minus 2 is minus 4. 3 times 2 is -6. Minus 6 minus 6. Let me just write it out. Minus 6i plus 4i squared. That becomes minus 12i. And that becomes minus 4. So that becomes 5 minus 12i. So this whole thing over here will become 5 minus 12i. And now we're multiplying that by 5 minus I. We're doing exactly the same thing again. We've got binomial multiplied by binomial. 5 times 5 gets me 25. 5 times I gets me -5i. 12i minus 12 minus times 5 is minus 60i. And minus times a minus is a plus. 12i squared. And this is all over 25 minus, now remember I squared is minus 1. Okay, so let's continue over here. Looking at that now, I know that this over here is -1. So that means that -1 times 12 will become -12. And 25 minus 12 will be 13. So that gets me 13 at the top. Okay. And minus 5 minus 60 is minus 65. And at the bottom, I've just got 26. Now we distribute the denominator to each. We get 13 over 26 minus 65 over 26. We're pretty much done over here, but 13 over 26 can simplify, so let's just simplify anyway. Can 65 divide by 26 and simplify? Yep, can as well. It become 5 over 2i. And so therefore, I have now written it in that form where I can see my a value is equal to half and my b value is negative 5 over 2. And I'm done. And I've written it in that initial form that I wanted, a plus bi. Okay. All right, let's have a look at this one. So I've got 13 plus 13i. I'm going to distribute the 13 at the top. Or I could keep it as a bracket. Maybe that's what they want me to do. Let's say I keep the 13 plus I together. And I've got 2 plus 3i in my denominator. I now multiply by the conjugate over itself. The denominator is going to become 4 minus 3i squared. The numerator, I've got 13. I can just leave that there and start multiplying. 1 times 2 gets me 2. 1 times negative 3 gets me negative 3i. I times 2 gets me 2i. I times negative 3 gets me negative 3i squared. Now we simplify the denominator. We can have 3 squared is 9. And I squared is negative 1. So it becomes minus 9. Are you okay with that?
Yep.
Okay. And then from there, I've got 13. Minus 3 plus 2 is minus 1. And then I squared is negative 1, so this becomes plus 3. Are you okay with plus 3?
I'm gonna figure out this. Okay.
So wherever you see I squared, wherever you see I squared, just remember multiply it by a negative and remove it. Yeah. So now 2 plus 3 gets me 5 at the top. And at the bottom, 4 plus 9 is 13. And I think that's why we kept it outside there, so it could cancel. Giving you 5 minus I as your final answer there. All right, so for this one here, you got 5 plus root 3. I root 3 is a root of a quadratic equation. Okay, so 5 plus I root 3 is a root. Find this quadratic equation. So we know generally quadratic equations have 2 roots. So can I safely assume that the other root is 5 minus I root 3? And if I do this, if I do assume that that is the case, then I can then create brackets from there, right? I can then move this over, z minus 5 minus I root 3 in a bracket, and z minus 5 plus I root 3 in another bracket over there. And now I can multiply all of this out. So let's take the z and the z and we multiply those two. We get z squared. Okay, and if I treat it as an equation, remember, keep this as a negative. So z minus that and z minus that. So let's keep it as a negative so we can keep the brackets in place. So when we multiply it, it's easier to read. So I'm going to put the brackets in. Just keep this as a negative. So I can see it in the form of a minus b times a minus b or something like that. You can see that. Okay, so just double checking. So this is supposed to be plus as well. It's supposed to be plus, yeah. Okay, so a minus b1 and b2. Okay, I got it in that form now, and that's minus, and this is plus. So z times z is z squared. I'm done. Let's go with the outer term now. Z multiplies by that, so negative 5 minus root 3 z and minus again 5 plus I root 3z. That's going to be the middle term. And then the last term is plus 5 minus I root 3. And these look like conjugates because they are conjugates. So they will basically, the I will become I squared and it will become a number. So the one is plus and the other one is minus over here. And the negative times the negative gets me a plus. Right, are you following that so far?
Yeah, I'm following it.
Okay. We now need to bring these two values in and we need to sort this one out. So let's sort this one out first. So we're going to 5 times 5 gets me 25 and minus I root 3 squared because it's a difference of 2 squared. So 25 minus I squared is negative 1. So it becomes negative 1 and root 3 squared is 3. Becomes positive 3. That whole thing becomes 28. Z squared is nothing much to do there. So the middle terms are the terms that I need to now sort out. So maybe let's distribute the z and the negative in, okay? So negative 5z plus root 3iz minus 5z minus root 3iz. Distributing it carefully, I can see that these two terms cancel out, and I'm left with negative 10z. So my final answer is going to be z squared minus 10z plus 28. All right, and that's going to be equal to 0. Remember, here we want to find the quadratic equation. We want to go backwards. And there we go. I've got the quadratic equation. Hold on.